Welcome to NASA's Summer of Innovation Lesson Support Videos. I'm Steve Cullivan, NASA Aerospace Education Specialist at the John C. Stennis Space Center in Mississippi. This video lesson will guide you through the NASA Summer of Innovation activity, I Want to Hold Your Hand. In this activity, we will construct a simple robot hand to help us explore how NASA designs, builds, and uses robotic hands, or as they're sometimes called, end effectors. Robotics has always been a major component of NASA missions and research. We use robots to study our Earth and worlds far out in our solar system or beyond. The word robot comes from a Czechoslovakian word, robota, meaning forced labor, and was first used in 1920. We like to think of robots as giving us a hand. One place we currently use robots is on the International Space Station. These robots assist the astronaut crew to keep the space station in top working condition. On board the ISS, you may find astronauts using a robotic arm to work outside the space station. Or you might find R2, or Robonaut 2, a dexterous robot helping with work inside the space station. Here are some images of an end effector at the end of a robotic arm on the International Space Station. These end effectors are what is used to grapple objects and move them around. Their use is similar to our human hands, but mechanically much simpler, as you see in these images. The image on the right is an image of the space station robotic arm itself. The image on the left is a close-up looking inside the end effector. This end effector uses a series of 3 cables that rotate and crisscross each other to grapple objects. This is an example of a NASA robot that has end effectors, or hands, similar to you and me. This is Robonaut 2, otherwise known as R2. R2 is a humanoid dexterous robot who recently arrived on the ISS. Not only can those hands salute, but they can lend the astronaut a helping hand with work in the space station. In the activity, I Want to Hold Your Hand, we'll construct a working robot end effector model that more closely matches our own hands. These are the materials you'll need. This materials list can be found on page 1 of the activity. Before you begin, I want to share some helpful tips I've discovered over the years. First, no matter what age you're working with, it really helps to cut those rubber bands, straws, and strings ahead of time. If the students cut out the cardboard, make sure you have rulers with centimeter measurements and scissors that can cut through cardboard. If you want to save time or need to cut the pieces for smaller children, you can cut the pieces ahead of time and have them ready to go in individual sets. Students can also work in cooperative teams of 2 or 3 for this activity. Now, I'll be using a separate camera to show you how to do each step in the construction of our robot hand. The 10 centimeter by 10 centimeter piece of cardboard will represent the palm of your robot hand. You can place that to the side for now. To start, the 3 2 centimeters by 9 centimeter pieces will each represent 1 finger. Take one of the finger pieces of cardboard and cut into 3 equal lengths as shown in this image. To complete the next step, place the 3 equal finger pieces together with the short side of the rectangles as the joints. Next, use a piece of tape to reconnect them. Label the side of the finger with the tape inside. Cut a rubber band 5 centimeters long. Next, turn the segmented finger over so the inside is facing down. Put the rubber band across the middle of the first joint. Tape the rubber band on both sides of the joint, making sure to leave about 1/2 centimeter of the ends of the rubber band untaped. Fold the untaped ends of the rubber band so that they rest on top of the tape and tape them firmly in place. This extra taping prevents the rubber bands from slipping. Now, we repeat these steps for the second finger joint. Now, turn the finger over so the inside is facing up and tape the finger to the palm. Turn your hand back over so the inside is once again facing down. Tape another 5 centimeter piece of rubber band across the last joint onto the palm, the same way we did the first two finger joints. You will repeat these steps for each of the other remaining fingers. After the other two fingers have been completed, cut 3 pieces of nylon string 35 centimeters long. It is best to tie a knot on each end of the string to keep them from unraveling. Tape the end of one piece of string onto the end of the first finger on the side with rubber bands. When taping the string, let the knot at the end hang out from the tape. This will help prevent the string from slipping out the tape. Turn the hand over so the rubber bands are facing down. Cut 4 pieces of straw 2 centimeters each and thread each piece of straw through the string taped onto the finger. Tape a piece of straw onto each finger segment and onto the palm. Be sure not to tape the string to the straws or joints. Repeat these steps we used to build this finger to construct the other two fingers. Congratulations! You now have a robot hand. You can operate the fingers by pulling on the strings. The string simulates the muscles in your hand, and the rubber bands simulate the tendons. Now that you have your robot hand constructed, you can have your students use their robot hand and discuss the conclusion questions in the activity. Also, observe the extensions in the activity to challenge your students to design and build different and perhaps better robot hands with more functionality. To see what robotic hands can do, you can follow the adventures of Robonaut 2 on Robonaut's website and see how this dexterous robot's hands are put to work at NASA. You can also visit the NASA Robotics website to explore even more about NASA and robotics. Thank you for joining us as we explore robotics together in NASA's Summer of Innovation. And special thanks to the many education specialists and the NASA Digital Learning Network who helped make this video lesson possible.